Moment of truth. Cool, I think I'm live now. So, yeah, we'll see how this goes. Hopefully this works. So that way, for those who are absent, they can go on YouTube and watch this. All right, let's get into some math, which you've all been waiting for. Hopefully by now you've got your notes or your free response questions up and ready to go. So like I was saying earlier, these are questions that I actually took directly from the College Board videos that they have been posting on YouTube. They go through and also kind of explain some of these problems, kind of walk through it. So these are the problems that I'm assigning to you. I'm basing a lot of our review off of that College Board review sessions that they're posting on YouTube, because that obviously is going to be the most accurate representation of what's going to be on the AP exam at this point, because, you know, the new format and everything. So that's what we're going to go over. I remember I've posted the link to where everything is on Schoology, so the College Board videos. Looks like I have another participant, Gary, here. Okay, let me update my Aries. All right, let's get into things. So this first problem here, and these are all problems that have to do with contextual applications of derivatives. So basically using derivatives in some kind of a specific situation. And we're starting with a cylindrical barrel with a diameter of 2 feet that contains collected rainwater as shown in the figure above. So there's our barrel that's in the shape of a cylinder that's collected rainwater. The water drains out through a valve which is not shown at the bottom of the barrel. So basically water is going to be dripping out from the bottom, and the rate of change of the height of the water in the barrel with respect to time is modeled by dH over dt equal to -1/10 times root h, where h is measured in feet and t is measured in seconds. The volume of a cylinder with radius r and height h is v equal to pi r squared times h. So we should know that volume equation already, but if not, they gave it to us. Part A says find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet, indicate units of measure. So basically it says find the rate of change of the volume. So they've already given us the equation here, dH over dt, that's the rate of change in the height over time, but that's not going to be the rate of change of the volume. For it to be the rate of change of the volume, we would need to have dV over dt. So that's going to be something that we need to figure out. And it's going to be with respect to time when the height of the water is 4 feet. So h is equal to 4. So we want to know what is dV dt equal to when h is equal to 4. Now we were given v here. V is equal to pi r squared times h. So I know that I'm going to need to take the derivative of that in order to find the rate of change of the volume. And I'm sorry I didn't give much room here. We're going to write at the top. So if V is equal to pi r squared times h, in order to find dV over dt, we will take the derivative. Derivative of V will be dV over dt. Remember, since we're taking the derivative with respect to t all the way through, then the variable would be t, and when we're taking the derivative of any other variable, then we have to multiply. We're using implicit differentiation, right? So we have to multiply by that derivative. So in this case, the derivative of v would be 1 technically, but then we multiply that by dv over dt. So we just have dv over dt. Pi is a constant. It's a number. So that's our constant multiple. We can just kind of keep that there. And then r squared times h is a product rule. So we need to apply that product rule here, which says we take the first times the derivative of the second. Derivative of h will be 1 times dh over dt, and plus the second, which is h times the derivative of the first. So that'll be r, sorry, not r squared. We're taking the derivative of r squared. That will be 2r times dr over dt. Okay. Now, at this point, we need to solve for this dv over dt, and we know that we want this to be when h is equal to 4. And if we think about it, this barrel is never going to grow in terms of the radius, right? It's going to remain the same. The only thing that's changing is the height. So we actually know that dr over dt is going to equal 0 because it's not going to grow or shrink. The radius will remain the same. And the radius will be equal to 1 because the diameter is 2 feet, so the radius is half of that. R is equal to 1. So these are all values that we're going to be plugging in to our equation here. And the nice thing here, we have pi, r is 1, oops, this should be dh over dt plus 4 times 2 times 1 times 0. So the nice thing is this is just going to cancel out to 0, right? So this will just become dv over dt is equal to pi times dh over dt. So we've gotten this at this point, but that doesn't give us the exact value of the rate of change of the volume because we don't know what dh over dt is. So we've got to figure that out. How are we going to figure that out? Haha, they gave us what dh over dt is, remember? dh over dt is equal to negative 1 over 10 times root h. So we just need to plug in the h value, which we know is 4, and that will give us this dh over dt value. So I'll do that over here. dh over dt is equal to negative 1 over 10 root 4. So that's going to be negative 2/10, which is negative 1/5. We'll take that plug it in. Over here we get dv over dt is equal to pi times negative 1/5, which will give us negative pi over 5. That is the answer we are looking for, because that is now our dv over dt. However, now the question is, what are the units? Because we need to have the correct units here. So it's the change in volume over time. So what are the units for volume? The units for volume are cubic feet, right? If the one-dimensional measures feet, then the volume is feet cubed or cubic feet. So we can say feet cubed, and it's a rate. So it's feet cubed per a unit of time. And what is our unit of time? Second. Okay. So that is our answer there for the first part of this problem. Yes, it took a while for just one part of the problem, so keep that in mind. Remember, for the AP exam, you're going to have 2 free response questions, and obviously one response question consists of different parts. So that's just one part of one question so far. Are there any questions so far? I went through that just kind of without stopping, so I want to stop and see if there's any questions. Otherwise, we will keep going to the next part. I need to check what our schedule for today is. We get out at 1:30. Okay. Cool. We're not going to finish all of these problems, so whatever we don't get through, that's going to be your homework due on Friday. So keep that in mind. Oh, I just remembered. So another announcement, sorry, pause between our next problem and the announcement. I posted on Schoology in the updates our schedule for if you're taking the AP exam. So I'm going to have a mandatory practice exam. It's scheduled for Thursday from 5 to 6 p.m. I know that's outside of school hours. I'm making it mandatory because we're going to practice the exam, going through it, uploading your problems and troubleshooting. So I want to make sure that everybody does that before the exam. So if for some reason you can't make it to the session, then please just let me know, so that way I can make sure and talk to you about what we are going to be doing in that session. Other than that, I have 3 other specific times where I'm just going to be helping AP calculus students. So that's going to be Friday, just really quickly, from 3 to 3:30. I'll answer any questions you have or any review. Saturday, from 11 a.m. to 12 p.m., I will do a review session, going over any questions. If you've been working on problems on your own and you're unsure of how to, find a solution, then that's your time to ask questions. And then also on Monday, after school, from 3 to 4 p.m. or however long it takes. It's the day before the exam, so I'm pretty much yours to just ask any questions before that day. And then your exam is on Tuesday. So that is my announcement when it comes to the AP exam. So please, if you can't make it on Thursday, let me know, and then we'll try and figure out or get you at least the same information so that you're ready for the exam. There is an option for a later exam, like a makeup type of day if for some reason you can't make it on Tuesday, but we can talk about that if you have questions about it. Okay, so we're back to the problem. We answered part A already. Now we're going to look at part B. It says, when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? So we need to explain our reasoning here. All right, let's kind of break this down. when height of the water is 3 feet, so this means h is equal to 3, is the rate of change of the height. So rate of change of height will be dH over dt. And we want to know, is it increasing or decreasing? So if the rate is increasing, that would mean its second derivative is positive. If the rate is decreasing, then that would mean the second derivative is negative. So that's an important kind of connection that needs to be made. We're talking about the derivative or the rate increasing or decreasing, not the original function, right? The rate. So this would mean the second derivative of h is either positive, so greater than 0, or the second derivative of h is negative, less than 0. Those are the two things that we have to check in order to determine if it is increasing or decreasing, if that rate is increasing or decreasing. So let's take a look at what we have. We were given a function here, dH over dt, so all we have to do is take the derivative of this, and that will give us the second derivative, because it's already dH over dt. Drop my stylus. Here we go. I'm going to do this in a different color so that I can come back up here and do it on this side. So I'll move this over here, then come over here and answer. So dH over dt is equal to negative 1 over 10 root h. I can rewrite that as a power. So we can just do a power rule here. So the second derivative will be negative 1 over 20 times h to the negative 1/2. And then I can rewrite that negative 1 over 20 times root h. Okay. So there's our second derivative, and we want to know what the second derivative is when our height is equal to 3. We want to know if it's increasing or decreasing. One thing I did forget here, which is really important, is where'd it go? D squared. Yes. Here we are. Our second derivative here, since we are taking the derivative with respect to h of this, we have to, or sorry, with respect to t, we have to multiply by dH over dt, right? This is technically still implicit differentiation. So if we're taking the derivative with respect to t of h, we have to multiply by dH over dt. So actually this second derivative is complete here. However, we need to go back and see what is dH over dt equal to, right? So we can plug that in, and that's going to equal negative 1 over 20 root h times negative 1 over 10 times root h. That means our h's cancel out pretty nicely. Negatives become positive. We get 1 over 200. So actually what ends up happening is our rate of change here is always 1 over 200, which is a positive number. So it's going to be increasing. Our second derivative is positive. It's greater than 0, so that means it is going to be increasing. It doesn't matter what h is equal to. It could be when the height is 3. It could be when the height is 2. It could be when the height is 5. Actually, depends on the barrel. I forgot how tall the barrel is, but I guess it doesn't say. But it's always going to be increasing. So we would say, because our second derivative of h with respect to t is equal to 1 over 200, which is greater than 0, or technically we can say this specifically, h has to be greater than 0, right? Because we're talking about h representing a height. So for h greater than 0, then that means the rate of change of the height is increasing. And the question was specifically asking for when the height of the water is 3 feet, so we can say when the height is 3 feet of the water, technically, height of the water. Right? So that would be the explaining your reasoning part, right? So we kind of talked through the initial information that they gave us. How do we break it down? How do we determine what they're asking us to find? And then from there, once we find our answer, that is how we want to explain our answer. The main part is here, the part that we figured out, that the second derivative, or the rate of change of the height, is 1 over 200, so that is going to be positive. Any questions there on that one? That was our first full free response question right there. Technically, so that's part A and B. Most free response questions go up to C and D, right? So you have A, B, C, and D. So this gives you an idea of how long one specific free response question might take, because those are just 2 parts, and remember that you might have more. So a lot of them will kind of connect 2 parts like you see here, and then maybe it'll have a part C and D that is somewhat connected using the same information, but not necessarily following one from the other. So it just kind of depends on the problem. All right, let's look at the next one. It says the height of the tree in meters can also be modeled by the function g, given by g of x is equal to 100x divided by 1 plus x. So this is only part D of another free response question. So if you want to look at the rest of the free response question, I would just look up free response question 2018, number 4, and you can see all the rest, A, B, C, and D. This is just part D, so that we're just reviewing the contextual part of the problem. So where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. According to this model, what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? So let's break it down again. The first thing, the most important thing, is when you're given a function, you want to recognize and be able to determine the input and output values. What do they mean? How does this function work? right? So here is the g of x function. So how does this function work? It says x is the diameter and g is the height of the tree. Sorry, let me close out of this queries real quick here. Okay. So we can plug in any value for x for the diameter in meters, and then the output would be your height of the tree. Okay. Now that we kind of have talked through that function, we get the gist of it, right? Let's go through the information they give us. When the tree is 50 meters tall, so that is our g of x, or our g value here, right? It's this y value here, g of x is equal to 50. The diameter of the base of the tree is increasing at a rate of 0.03. So diameter, remember diameter is based off of x. So basically this is saying g prime of x is increasing at a rate of 0.03 meters per year. According to this model, what is the rate of change of the height of the tree with respect to time at the time when the meter is 50 meters tall? So we need to figure out what is the rate of change of the height. We need to figure out what is g prime of x, right? So this g of x, we need to take the derivative of it. It's a quotient rule, so I'm going to start with the bottom. We've got low, d high. The derivative of the top will be 100 minus high, d low. So the derivative of the bottom will just be 1, and then we will square the bottom, x squared, and multiply that by dx over dt. Technically still the same idea. This is implicit differentiation because we are measuring this in time, right? It's the rate of change with respect to time. So we are taking, sorry, I wrote this incorrectly here. The derivative with respect to time. And our function only has x values here. So we have to multiply by dx over dt. Now that's our derivative here of g prime. And this value here, I can rewrite this as dx over dt because this is telling us this is the rate of change of this diameter, right? The diameter is represented by x. So this is dx over dt equal to 0.03, which we can go ahead and plug into this value right here. So if I simplify this a little bit, we will have 100 plus 100x minus 100x. Actually, that will just cancel out. And divided by 1 plus x squared times 0.03. Okay. Good so far? Any questions? So what is it that we were trying to find again? What is the rate of change of the height with respect to time t? So we've found that rate of change here. We want to know when the tree is 50 meters tall. Okay, so the tree is 50 meter tall.
Miss Marta,
Yes.
could you where's the 6x come from?
6x, 6x, 6. Oh,
It's G, right? Is it?
yeah,
Oh,
sorry. That's a G. Yeah, I should make my G's look like actual G's. There we go. G of x is equal to 50. Okay, so we have this function here. Remember, g of x is representing the height. So g of x is equal to 50, but our function here for the rate of change is in terms of x. So what we want to do is we want to actually plug in this value of g of x to the function and then solve for our x. And we'll actually get x is equal to 1, right? We can multiply by this and then kind of combine all our like terms. We get x is equal to 1. So then we can go ahead and plug that in here. 1 plus 1 squared times 0.03, which gives us, once you simplify it, actually gives us 3/4, all the way simplified through. Okay. This one was kind of complicated because of the fact that we're switching kind of the variables throughout the functions, right? We're given here, let me find an empty space, g of x, oh, make that look like a g. G of x is equal to 100x divided by 1 plus x, right? But it's asking us to take the derivative of this with respect to time. So that is why we have to end up taking this derivative and then multiplying it by dx over dt. Because this function is in terms of x. Right? So if you're taking the derivative with respect to time of a function that is in terms of x, we have to multiply by that dx over dt. Any questions on that?
Could you explain how to take derivative of 100x divided by 1 plus x?
It's a quotient rule because it's division.
Oh, yeah.
So we went through, right, low would be 1 plus x. D high would be the derivative of 100x is just 100. Minus high d low, the derivative of 1 is 0, derivative of x is 1, and then square the bottom. Okay. And then that's multiplied to dx over dt. Other questions on that? Okay. So that covers those first two problems that you see there. We have the next one about the boiled potato. And I'm actually going to let you work on this one on your own. We have about a little over 10 minutes of class time left. So I'm going to let you get started on that, and I'm going to stay on here to answer any questions that may come up as you're starting to go through this problem. And then we will just be meeting again on Friday if you are not taking the AP exam, but if you are taking the AP exam, then I should see you on Thursday at 5 p.m. We're going to be using the tutoring link. So there's a tutoring Zoom URL that I posted.
Is the mandatory exam going to be graded? Or it's just practice?
It's practice exam. Yeah, I mean, technically it will be graded so you can see how you did, but it won't go into your grade.
Okay.
Well, let me know if you have any questions, either with this last problem that you have for homework or with the review sessions that are coming up in the practice exam.
I want to ask like what changed this year for the AP exam? It's only 3 response question. So there's no multiple choice.
No multiple choice.
And
It
how many
used to be
there?
how many what?
How many questions are going to be in AP exam?
It's going to be 2 free response questions.
That's it?
That is it. Yes.
Well, there's only 2. That's it? How long?
Only 2 problems. Yeah. It's going to be 45 minutes total for those 2 questions. And they're going to time you for each question. And they'll give you, I think they said actually, it'll be, I can't remember the order, if it's 20 and then 30 or 30 and then 20. But they give you a little extra time to upload.
Okay, so they gave you 45 minutes for 2 questions. Mm-hmm. That means like, is it a question like this or it will be much longer?
It'll be almost like this, but usually it's got 4 parts, so it'll be A, B, C, and D. So if you look at, like, for example, here, this next problem, I've only included parts A and B. So you can expect probably a part C and a D.
Okay.
Or like for this one, I only included part D. So you probably had A, B, and C also to go along with it.
Okay.
Yeah. So we will be kind of practicing how to upload and do that on Thursday. But just so you know, that's it. This is your whole exam. So that's why we're going through these kinds of problems so you can get familiar with it.
Okay.
Sydney, I see your question. Can you explain taking the derivative with respect to time? Sure. So when we started kind of talking about functions, right? A function has the input and the output. So maybe you have a function, let's take this function here, for example, g of x, right? So this g of x, the input of x is the diameter, and the output is the height, right? So your diameter is represented by the value of x, and your height is represented by g of x. So if you were to take the derivative of this function here with respect to x, so then that would mean you're taking the rate of change of the height, because I could technically rewrite this by putting g of x at the top and dx at the bottom. So this would mean this is the rate of change of the height as the diameter changes, right? So that's what, if we were taking the derivative with respect to x, then it means how much the height is changing as the diameter changes. But what we want to know is how much does the height change right? We want to know g of x, how much does the height change over time? And so kind of going back to this question, the key phrase right here, change of height of the tree with respect to time. So whenever it says with respect to something, you know that's going to be the bottom part. D of t, that's with respect to time. And then the top part is what is it that's going to be changing? In this case, the change of the height. So d of g of x, because height is represented by g of x. So the change in height over the change in time. So if you are given the g of x function, this just means you have to take the derivative d over dt of that g of x function. So the problem with that, it's not really a problem, it's just the thing that you have to keep in mind is that now, since you're taking the derivative of this function, g of x, that is all in terms of x, right? That's the only variable in g of x. You're taking the derivative now with respect to time, then you have to use implicit differentiation because this is a new variable now. So you're multiplying it, whatever the derivative actually turns out to be, you're multiplying it by dx over dt as well. Does that help explain a little bit more? Is there anything else you want me to clarify? That helps. Awesome. I know it's a tricky concept to kind of fully grasp. And especially when you're taking the wording, the phrase there that you see, change of height with respect to time, and then translating it into an equation can be a little tricky. But as long as you kind of take it, remember every equation is just our language. It's a different language, right? So you want to just kind of see how does it match up and translate.
So why we need to multiply derivative x over derivative time at the after we take the derivative of the gx?
Because g of x only has variable x in it.
Okay.
So they're different variables. So you always remember when we did all the related rates problems, even with the one that we did right at the top here, it might look more familiar when you see it in this form, right? We had to multiply by dh over dt and dr over dt because we were taking the derivative with respect to time of those different variables. So it's the same exact thing.
Okay. Okay.
Any other questions? Things I can clarify for you? We have just a few more minutes, so I will just kind of wait around here, answer any other questions that may come up. Otherwise, make sure you complete this for homework. You can stop by tutoring maybe later today or tomorrow or Thursday if you want to. Now that you've kind of, once you take time to work on it, you have questions, I can help out with that.
So I want to ask, tutoring. Are you tutoring after?
Yes, so I'm tutoring today, right after this class, from 1:40 to 2:30. Tutoring tomorrow from...
So where is the link?
If you go to Schoology, you go to updates, you'll see the link. I posted it like a few weeks ago, and it just says tutoring with Miss Martin, Zoom link, or something like that.
Okay.
All right. I hope you all have a great rest of your day. If you are just going to work on your own for the rest of class, you only got about 3 more minutes. You're free to just do that. And I'll see you on Friday, if not sooner.